In the previous example of flyers hung based upon hours worked, we see a very strong linear relationship. As the hours worked increase, the number of flyers hung increases in a fairly consistent manner with some natural random fluctuation. Picturing a linear model, least squares regression line, we can see that it has a positive slope and the actual points fluctuate randomly above and below this prediction line. As x goes from smaller values to larger values, how are y values related or associated? When talking about the association of two variables, we address three factors: strength, direction, and form. These points hold very close to the prediction line. Thus, there is a strong association. As x values increase, y values also increase. This is a positive association. The line has a positive slope. The association is also linear. Y values are closely associated to the x values via a linear model, a line of best fit. So we would describe the association, the relation between flyers hung and hours worked, as strong positive linear association. Let's quickly look at examples that have different combinations of these three descriptors. Weak positive linear association. The points are much more spread out. Therefore, the prediction line is not as strong in its ability to predict flyers hung based upon hours worked, hence weak positive linear association. We may see a strong positive nonlinear association because the rate of flyers hung per hour are declining as time goes on, not a straight line relationship. Returning to the example of pain declining as more milligrams of pain medicine is given, there is a strong negative linear association. Let's get familiar with the term correlation. Technically, correlation is only to be used if there is a linear association between two variables. Thus, the strong positive nonlinear association should not be called correlation, but both of these scatter plots describe strong correlation because the association is linear. The term correlation is often misused in the media and business world. For example, suppose female voters are generally in favor of a certain political candidate while men generally prefer a different candidate. Media sources have been known to say things like there is a correlation between gender and candidate preferred. If you claimed this as an accurate statement on an AP exam, you'd lose points. The graph to display the difference in approval rate of a candidate between males and females would be a bar graph, not a histogram, because the gender variable is categorical. And this is definitely not a scatter plot for the same reason, so this is not a linear association. Correlation is therefore an incorrect descriptor. Now, we could replace female with the number 1 and male with the number 2, and look, a scatter plot with two ordered pairs. Now is it okay to use the term correlation? No, because arbitrarily assigning a female the number 1 and the male the number 2 has no numerical significance other than to categorize the two groups. Hence, the numbers 1 and 2 are still categorical variables and not quantitative. It's fine to say that there's an association between gender and candidate preference, but it is not okay to claim correlation.